Okay. Well, thanks everyone for coming. So this book, There's No Planet B. So I've been working in this field of climate change for 10 or 15 years, and the more you think about climate change, the more you realize that actually if you actually want to deal with it, you need to see climate change as a symptom of something much bigger that is going on. And so let's have a look at what that bigger thing is. And this book is my attempt to look at that bigger thing. And so the best way to start talking about it really is to have a look at this graph of global energy use by humans. And it's been going up and up and up and up. And for the last 50 years, it's averaged 2.4% per year, which is, at that rate, it's a factor of 10 every century. And before that, for the 100 years before that, it was only going up about 1% per year, and before that, a smaller rate. But we've always been getting more and more energy at our disposal. And not only that, but we've been getting more efficient in our use of energy, so we can do more with any given amount. And we've also been inventing new things to do with our energy all the time. So new chemicals, new plastics, new ways of blowing people up, new ways of traveling, all kinds of different stuff. And the upshot is that, through all this, we've been getting to be a more and more powerful species all the time. And one of the things that happens is that we influence the planet that we live on through a mixture of accident and design more and more. And for a long time, over the millennia, it didn't matter that we were getting more powerful because the planet was still a big, robust place compared to us. And we've been able to get away with treating the planet like a big, robust place until very, very recently. So 100 years ago, we couldn't smash the whole place up, even if we tried. And we did try quite hard. And 50 years ago, we got more powerful. We got to the point where we realized with a shock, actually, you know what? We could smash up the whole world if we put our minds to it, if we did something really stupid, like have another big war. But in the last 50 years, we've got 3 times more energy at our disposal. We're a lot more efficient with its use. We're a lot more inventive with its use. We've invented all kinds of plastics and so on. And one way and another, we've got to a point where now we don't have to be particularly careless to smash the world up. We will smash the world up now, rapidly, and we are doing, unless we dramatically improve the quality of our stewardship over this planet. And it takes us into a brand new context. And some people use this big word, the Anthropocene, just to mean the era suddenly in which humans are the biggest thing that's influencing the planet. And so my simple little diagram, just to illustrate, this concept is that we used to be able to treat ourselves like that, small species running around on a big planet, and suddenly it's like that. And it's a completely different context for humans to operate in. And in this new context, it's very unclear how much of everything about how we do life is still fit for purpose. Because if you look at our economics and our politics and our decision making and our problem solving and the way we run our societies and our lives and just about everything, it's all been honed in this era. And now suddenly we're using it in this era. And so what we need to do now is we need to identify which bits are not still fit for purpose, and then more challenging still, we need to change them urgently. Because we're going to be in a lot of trouble if we don't. And it's kind of frustrating, you can argue that we do actually have the opportunity, if we played our cards right, to live better than ever, but if we're not very careful, we're going to be living worse or not at all. And it is a small time frame now that we have to deal with it. So here in this Anthropocene, what we're faced with suddenly is a whole load of global challenges which are interconnected. You can't deal with climate change on its own and then turn your mind to how to feed the world's population and then have a look at biodiversity and then ask yourselves about questions about inequality and then have a look at politics. Actually, you have to look at all these things together. So the book is kind of my unapologetic attempt to try and cover off absolutely everything that matters through the lens of every single discipline, all in one short, chatty, accessible, fun but serious book. So there it is. And and I've said that it's not about looking at things one part at a time. Really, you need to look at it all simultaneously. So what I'm going to do is I'm going to keep quiet for the next half hour and just ask you to look at that and then just try and absorb the whole lot in one go. There will be a test at the end. But there it is, and it's full of, you can see it's full of diagrams and stats and so on. And the reason it's got all that is because, just come in. It's because I put in statistics whenever I think that they are perspective forcing, because I think there are stats in here that really should make our eyes pop out. How much damage are we doing at the moment, and how much opportunity is there to live better and sort things out, and why on earth are we living like this when we could be living like this? Just before I go any further, I just want to quickly cover off one thing, because the book's called There's No Planet B. So I just want to check, is there really no Planet B? And this is a piece of fun, but it's also deadly serious, because I was brought up on Star Trek and Star Wars and all that kind of thing. And there was a time in my life when I think I assumed that the future really would be bombing around between the planets at some stage. And Elon Musk talks as though that is what the future is going to be. And even Stephen Hawking, before he died, said something on the lines of, well, we're not going to be leaving the planet for at least another 100 years, so we need to be very careful in the meantime. And that kind of, to me, that sort of implies that maybe not long after 100 years, we might be seriously leaving the planet. So let's have a look. So just a bit of GCSE level, junior level physics here. So the nearest planet that might be any good to live on is pretty local in terms of the universe. It's only 4 light years away. And so if you're prepared to have a long journey, a 40-year journey, you only need to travel at 1/10 of the speed of light to get there. So let's have a look at the kinetic energy that a person traveling at 1/10 of the speed of light has. And this is just a person traveling through space in their underwear, no spaceship, no nothing, which of course is instant death. But it turns out to be the same amount of energy as 500,000 globally average people get through in a year. Right? That's just one person flying through space in their underwear. If you start giving them a spaceship, so I did some fag packet sums, I gave them a spaceship about as big as my Peugeot 107 little car, which I definitely wouldn't like to spend 40 years in. And then some kit so that they can survive the 40 years without getting too bored, and some other stuff to help them start up their new life when they reach their destination. And then maybe some kit to help them slow down when they get to the other end so they don't crash into their new home at 30,000 kilometers a second. If you start taking that into account, what you find is that the whole of humanity's annual energy supply is only enough to get a small handful of people on that journey. Right? That's the whole of humanity's annual energy supply, leaving nothing whatever for the remaining 7.5 billion. So the point I'm trying to make is that just from a simple energy perspective, it's absolutely not, it's not happening at all, not for this generation, next generation, the one after that, the one after that, the one after that, or the one after that. So we're stuck on this beautiful planet A of ours. So we better make the most of it. So Star Trek is fiction. Okay, just a little collage of some of the. I said it was a whole lot of interconnected challenges. So a little collage of some of them. So, we've got biodiversity things to think about, just as pressing as climate change. And one of the species, of course, is that one. Which there are more and more of every year, so that's another issue, important part of the equation. And we're on this beautiful planet, but we're filling it up with plastic, as we've been hearing about. And all those people have to eat somehow, so there's some food, and it's got to come from somewhere. And some of it comes from things like this. That's a battery chicken farm. Some of it comes from places like that. Some of it comes from some sheep, like we've got just outside the door here. And 2/3 of the world's antibiotics get fed to farm animals at the moment, and there's a kind of a looming antibiotics crisis, which is kind of possibly another angle on another challenge we need to face up to. And then finally onto energy, and our energy comes from somewhere, and most of it comes from sources like that, and a little bit comes from sources like that, solar panels, and a tiny bit comes from wind turbines, and there's just one symptom of climate change. And just to continue the mix of challenges. So we've all got to live somewhere, and some people at the moment live in places like that, that's London, and some people live in places like that, which could be any one of hundreds of places around the world. And one of the questions is, if we really want to deal with something like climate change, and we'll go into this later, is it actually possible to deal with climate change without dealing with some of the inequality, with that level of inequality that we've got going on in the world? And we'll talk about that later. So there it is in pictures, and here it is in words. So the book is it starts off about some of the physical challenges that there are to deal with. So, there we are: energy, climate emergency, food, ocean acidification, antibiotics, population, biodiversity, plastics, other pollutants. And while we're dealing with all that, if there's going to be any transport, we have to look at how we're going to manage our transport. So those are the kind of some of the physical challenges we need to deal with. And I'll just give you the one-liner on that, which the really good news is that from a technical and scientific perspective, there is no reason whatever why we can't deal with all of those things nicely. Right? The solutions to all of that are there waiting to be had. So the real question becomes, well, all right, what would it take for us to be dealing with these for us to be applying these technically solvable solutions? And that takes us into a whole load of other stuff. Questions about growth, questions about technology and how we treat technology, our attitude to it. Big questions for business and the role of business in the world. Huge questions about politics, how we do politics, the state of democracies and so on. Questions of truth and trust, possibly the crunch point of the whole book, questions about values. What kind of values will allow us to thrive in this Anthropocene? And are there some values that if we hang on to them, we just won't thrive? And if we need to have certain values, then can we change them through our own deliberate action? And then questions about economics. It's totally unsurprising that a whole economic framework that was developed before the Anthropocene may not be fit for purpose in the Anthropocene. And related to that, the metrics, and as I've mentioned, inequality. So there's a whole load of other stuff, and then the conclusion of the book has some stuff about thinking skills and habits, and maybe there are some ways of thinking that humans absolutely actually need to develop their skills at rapidly in order to kind of balance our evolution. We've developed we've technically developed into a fantastically sophisticated species, and now maybe we need to balance that out at high speed with some evolutions in the way that we think. And I'll talk about that at the end. So I'm going to get into the detail of some of the green stuff, and I'm going to start off with food and land, and this is based, a lot of this chapter, it's the first 60 pages of the book or so, and it's a lot of this work is stuff that we did at Lancaster University. And so this is just looking at the global food production in human edible crops. And the green bars, the red dotted line shows you is set at 2,350 calories per person per day, which is the global daily human requirement. And you can see all these regions of the world, we're all in surplus actually. So we grow a huge abundance of food. It's fantastic. And there we are, the world one at the end. We're growing 6,000 calories per person per day nearly 2.5 times what we need. In America, it's more like it's almost 20,000 calories per person per day, but every continent has got a good surplus. And you can do a similar chart like that for all the micronutrients and protein as well. It's not just calories. I'm just showing calories for speed. So let's have a look at why isn't there just a massive surplus of food? Let's have a look at what happens on its journey from field to fork. So there it is again in green. That's the human edible crops, the nearly 6,000 calories of human edible crops that we grow every year. And in brown below it, I've got the 3,800 calories of grass, pasture and stover that we feed to our farm animals that we can't eat, but it's still an energy source for them. So I've included it in brown. So let's have a look at what happens to it. Well, sorry if some of the text is a little bit small, but there's a bit of harvest losses, and we can cut that down. If we're smart, we can cut that down, maybe cut it in half. But there's still plenty of food. And then there's some post-harvest losses. That's a storage thing, and it's mainly a developing world problem, and it's about food that's been harvested just just rotting before it's eaten. And we can solve that. You know, we ought to be able to deal with most of that and cut that right back. But anyway, there's still plenty of food left. 5,265 calories per person per day at the global level. So this is the really interesting stage. What do we do with it? The thin yellow sliver at the top there is the bit that we save as seeds to plant for next year so we can eat next year as well. And that's a really good idea. So that's well spent. The blue section below that, near about 800 calories per person per day, that's non-food uses, and that's mainly biofuel, which isn't bad as such. But just to give you an idea about the trade, so this is human edible food being used for biofuel. And just to give you an idea of the steepness of the trade-off, I mentioned my little Peugeot 107 1-litre car. If I grew enough wheat to feed me for a day, give me all the calories I need for a day, but instead use that wheat to create biofuel to power my car, I could power my car for 1 mile. Right? So that's a day's worth of food for me traded off against 1 mile of car driving. That's an incredibly steep trade-off. If you use a second generation biofuel using maybe a cellulose crop, which we don't quite know how to do properly yet, but assuming we can get there, we might get 5 miles in exchange for a day's food, but that's still an incredibly steep trade-off. So we need to watch that like crazy. Supposing we to work out to leave the fossil fuel in the ground, which we do need to do, then if we just let the free market do its thing in the food system, you can easily imagine a world in which a lot of food is getting diverted to biofuel at the expense of everybody else having enough. And then there's a big green section, crops for eating. That's fine, that's good. 2,500 calories, still a surplus, fantastic. And then the big brown section there, edible crops fed to animals. That's 1,740 calories per person per day. Nearly 3/4 of the calorific requirement of humanity is being fed to farm animals in human edible crop. So what happens to that? So the farm animals eat these 2 chunks here. So they eat masses, and they give us back the red chunk there, nearly 600 calories per person per day. They give us some back, but look at the enormous animal losses in grey that you've got there, nearly 5,000 calories per person per day. And that's animals doing inefficient things like walking around and keeping warm and stuff. And of course, if you want to minimize that, you can. The way to minimize that is you put them in really crowded small spaces, and you pack them full of antibiotics so they grow quickly, and then you kill them quickly so they don't get much chance to do anything like walking around or having a life or anything. If you can improve the efficiency, if that's how you want to view animals, a bit, somewhat, by doing that. And we do quite a lot of that at the moment. So just to continue the story, then there's distribution and processing. And so households get about 2,000 calories per person per day. And then consumers waste a bit, about 260 calories per person per day in this, at the global level, much more in this country, much less in some other countries. But overall, there's still a net surplus. So what does all this tell us? So I've mentioned about biofuels. Obviously, we should cut the food waste wherever we can and the losses, and we could probably cut those in half if we put their mind to us. But the biggest story in this is that if we could just stop feeding human edible crops to animals, which would mean a huge change in our diets. It means we don't have to go vegetarian or vegan, but we do need to change the proportions a lot, and there's an abundance of evidence for this. Then we would free up so much capacity in the food system to manage our biodiversity better, feed a growing population better, and deal with climate change. And just to say, the other thing that comes out of this for me is that there is an abundance of food. And you can do this diagram for protein, iron, zinc, and we've done it, and you get a very similar story. There is actually an abundance of food at the moment. The reason why some people are going malnourished is not because there isn't enough food. It's because the supply chains are not finding their way to every mouth. And that's because in a market economy, it's just not financially worthwhile pushing it towards every mouth at the moment. And so some things, if we are serious that we want a world in which everybody's nourished properly, something's got to change about that level of inequality. Right? If at the moment the way it works is that if there's more money in creating some asparagus and putting it on an aeroplane for people who are 1,000 times richer than some other people who actually need the nutrition, then the money goes into the asparagus on the aeroplane or into the biofuel for some of these private jet or whatever, rather than actually where it needs to go. And so the point I'm making is that we could create as much food as we like, and we would still have people malnourished if we don't deal with that end of the inequality problem. Okay, just to emphasize the inefficiency of having animals in the food system, I'm not a vegetarian or a vegan, by the way. I'm sort of moving by degrees closer and closer, but I'm not. Flexitarian, thank you. I'm one of those, yeah. So this is just, comparing 100 grams of soybeans with 100 grams of beef in calories, protein, iron, and zinc. And the 100 grams of soybeans wins every time out, even gram for gram. I couldn't believe it when I first saw this. And yet, if you feed 100 grams of soybeans to a cow, you'll only get about 10 grams of beef back again. So there's huge inefficiency in that. And I've mentioned the antibiotics thing. 2/3 of the world's antibiotics, at least, going to farm animals. Even in the Lake District, actually, antibiotics and human edible feed going to farm animals. Then just quickly on food and climate change, the carbon footprint of 50 grams of protein, which is about what we need in a day. And I won't go into too much detail, but just at the top, the very high numbers there, you've got beef and lamb, the highest carbon animals, because they burp up methane as well as being animals. And then sort of other animals in the middle there, still pretty high carbon, and just dramatically less. The bottom 6 or 7 bars on that chart are the plant-based forms of protein. It'd be wrong to move on from the food discussion without just talking slightly about what's going on in the sea and the fish. So the book, I should say, is laid out in questions. So we've got about 120 or something questions. I haven't even counted them. But one of the questions is, when's a sea bass not a sea bass? And the answer is that when it's a Patagonian toothfish that's been renamed purely for marketing purposes, and actually comes out of the Arctic Ocean, from the deep ocean, possibly 3.5 kilometers down, and takes 45 years to grow. So once you've fished it up, it takes 45 years before you can have a new one. And 80% of it is coming from unregulated fishing, which we're talking about slave ships just out at sea, refueling out at sea, unloading their catch out at sea, never coming anywhere near a port or anything that can regulate it. And if you don't know when you go to the supermarket that your sea bass that you're buying isn't in that supply chain, then there's every chance that it is. So we could be eating, at the global level, we could eat 30 grams of fish per person per day if we really sorted out how we do our fishing and regulated our seas properly. But there is absolutely stacks of work to be done on that. So it's not that we can't have any fish, but we need to keep treating it as a treat. So just quickly, the food, what does this mean? So the book is trying to be sort of scattered with, suggestions at the individual level and also at the kind of global level as well. So less red meat, and particularly less of every kind of meat, less dairy. We need to get much better at eating everything that we buy. We need to treat fish as a treat, and we need to get to know our supply chains so that we really understand when we see something on the shelf, and this isn't just about food, but we need to tune into when we see something on the shelf, we need to ask ourselves really carefully, well, how did that come to be there? What was the life? What was the journey that led to it being produced? And that needs to be part of the equation when we decide whether to buy it or not. And then at the global level, it's a lot of the same things, but we need to also reduce inequality. We need more farmers on the land, and this applies locally as well. We need more farmers, not less, on the land. The most financially efficient thing to do has always been to reduce the number of farmers it takes to grow the crops. But actually, that's crazy, isn't it? We've got people coming out of our ears, and we're going to have even more of them coming up soon, like it or not. And one of the best, it takes skill to grow, to do the right thing with land, to make it productive and biodiverse and so on. And actually, that takes more people, not less, if we want to do a good job of it. And as I've said, a lot of work to be done on how we do our fishing. I can't cover everything in the book, by the way, so I'm going through a few highlights. So just quickly, a statistic on plastic, which is one of the most depressing things in a way about the environmental crises that we're building up, because we've sort of drifted into that plastics thing, haven't we? 50 years ago there wasn't any of it. Now there's loads of it, and actually, there's nothing we can do to ever get rid of that stuff on beaches and at the bottom of the deep ocean. It degrades in the sense that it falls into smaller and smaller pieces, but it's still there. And if it was all cling film, you could wrap the world up 1.5 times in it. That's how much it is, just the discarded plastic. Okay, on to energy and climate change. Well, at the back of this book, I'm just going to say a few things about it now. At the back of this book, there's an appendix with 14 things that everybody needs to know about climate change. And there's a request that anytime you vote, please don't ever, if you get a choice, please don't ever vote for anybody who doesn't get all these 14 things about climate change. So there's a little tick list for you the next time you get a chance to vote. But just a few of the most important things to say about climate change. So this is a curve of emissions from fossil fuel use, from energy use. And the thing to notice about that is that it is still going up exactly as if humans had never noticed that climate change was an issue. And I am being exact in my words. It is exactly the same. There's not the faintest evidence at all that it's responded to humans having noticed climate change. And I'm not saying this to be depressing, but it tells us a lot about the kinds of things that we need to, the kinds of things that won't solve the problem, and if we do want to solve the problem, what kind of thing might help us. So, it's weird, isn't it? Because we all know people who've done things to cut their carbon footprints, plenty of people like that in this room, me included. And we know that the government's got targets, and we know businesses that are trying to do things. And how come it all sums up to nothing? Well, the reason for that is that at the global system level, there's a big dynamic going on in which if you have a small change, if you reduce the emissions in one place, actually somewhere else in the world you get an expansion to fill the gap. It's a bit like squeezing a balloon. You squeeze it in one place and it just pops up elsewhere. And that tells us an awful lot. That tells us that we need to do something that interrupts that dynamic at the global system level. And this is explained in more detail in the book, but so what it tracks back to is what we must have is a global arrangement to leave the fossil fuel in the ground. And yeah.
I was just curious what happened in the 80s.
Oh, we had an oil crisis. Yeah. And if you
correlated things to that.
Yeah, and if you look at the carbon curve back to 1860, you can track it to Great Depressions and World Wars, and it wobbles a bit, but it stays on an exponential trajectory. Yeah. So that tells us we need to have a global deal to leave the fuel in the ground, and it doesn't matter how hard we think it is to arrive at that deal, we must focus on getting it. And so anyone who wants to deal with climate change needs to be asking the question, what can I do to help create the conditions under which the world will be able to leave the fuel in the ground? And, that's how much fuel there is in the ground, that big bar there, and the little bar on the end here is how much of it we can burn even to stay within 2 degrees, which of course we now know is incredibly dangerous. And there's the most interesting, fascinating part of the human, of climate change is the human response to it. And the good news is, that I think there is some evidence that humans are that head is starting to come out of the sand. It's nowhere near out far enough yet, but I will say it's a lot further out of the sand than it was, a year ago, or certainly 5 years ago when I wrote my last book. So I don't want to be too chirpy about this, but there is some evidence that we might, if we all push hard, be on the verge of something that actually could be useful in dealing with the problem. I'll just quickly on this, so just to make the point, everything we dig up gets burned. You can measure carbon footprints in 3 places. This is a cheat. This is a slide from my last book, actually. But I'm putting it in for a local reason. So you can measure carbon at the point of consumption or at the point of burning it, and that's the point of combustion, or you can measure it at the point of extraction. And whichever point you add it up at, you should get roughly the same number. So we need to cut the carbon footprint of human consumption, and we need to cut how much we're burning, and we need to cut how much we're digging it out of the ground, because if it comes out of the ground, there's only one thing that's going to happen to it. It's going to get burned to meet a human need. And I say this because there's talk of opening up a coal mine off the west coast of Cumbria. And one of the arguments that's been used to try and it's an unspeakably stupid thing to do. It's going to have a carbon footprint of about 500 million tonnes. That's the coal that's going to come out in its lifetime. Ridiculous. And one of the excuses that's being used is it's okay because we're going to export most of the coal, so it won't be our problem. No, seriously, that is part of the argument for it, and it's completely bogus. For speed, I'm going to have to cut some of these slides a little bit. But so there's our energy supply, and the thin little green slither is the renewables. And we need to expand those renewables over the next not many years to replace the biggest 3 chunks of that pie, which are all fossil fuel. So that's the difficult message. Now I've got some good news. I've actually got some really good news. So there is a picture, and this is to scale. The black dot there is the size of solar panels that we would need to replace the whole of humankind's energy supply. 228 miles by 228 miles. That's fantastic. That's all we'd need. Now, and there's no reason why we can't have those solar panels. There are some resource burdens, but they're not show-stopping, actually. And there's problems about how we distribute it and how we store it and so on. But actually, it turns out that all those problems are solvable as well. And there are places that don't have sunlight, but they've got other sources like the UK. We've got bits of wind and tide and stuff. And when you look at all this stuff, actually, it turns out to be solvable problems. But here's the real crunch. I said that our energy supply is going up by 2.4% per year. So we've got to make sure that our renewables replace the fossil fuel rather than having it as well as the fossil fuel. And we're set to double our energy supply by 2050 if we're not careful. So we have to stop doing that. This is what would happen if we stay on the energy trajectory. That's what the top left is what it looks like now, 1 dot. In 100 years' time, it would look like that, 10 dots. In 200 years' time, it would look like that, 100 dots. And in 300 years' time, it would look like that with every scrap of the world's land area covered in solar panels and some of the sea as well, and no sunlight landing on humans at all, because it would just be a waste of solar energy. So the point I'm trying to make is we've got to stop growing our energy supply at the global level as well. If we're going to get this global deal to leave the fuel in the ground, then we're going to have to look at how we share around the energy supply, the alternative energy supply that we've got. So here's a map of the sunlight that hits the world. And the color scheme shows you the sunlight per person. So dark is good, lots of sunlight per person. Fantastic in Australia. They get 200 times more sunlight per person than we get. And if you look, you can just see the UK looking very skinny and pale up there. And we are the 5th worst country in the world in sunlight per person. We're just ahead of Bangladesh, Rwanda, the Netherlands, and Belgium. But it just raises the question, what would it take if we're going to have this global deal? Somehow we've got to find a way of sharing out this new energy supply, with some countries being so abundant and some countries not. If you line up the energy supply with the fossil fuel reserves, this is the countries with the top fossil fuel reserves, and this is the countries with, and this is how much of the world's sunlight supply they've got. And the good news is that most of the time, not all the time, but most of the time, they line up quite nicely. The countries with the most fossil fuel also have really good sunlight. A quick map of the wind, of who's got the most wind energy, and I just put this on to reassure people in the UK, because there we are looking slightly more filled out and slightly more colourful. It's not great, but it's enough to get by. Okay, just a couple of snippets on land and transport. There's a whole lot of this in the book, but that's just all the world's travel miles at the moment. 27 trillion travel miles that we do. The green is walking, the grey is driving, going up and up and up. The red is rail, that we need more of. The walking, by the way, includes everything. If you go between the fridge and the kettle in your kitchen, that's included in there. We've counted it. Not necessarily exactly, but we've done our best. And the air, and the air miles are the most carbon impactful of them all, and they're rising worryingly as well. But come the low carbon world, just about all transport is going to require land one way or another for it to happen. So I'm just a quick illustration of some of the ways in which we could use that land for travel. So we've got 4 different ways of doing it. One is you grow a grass, a cellulose crop for a second generation, more efficient biofuel, and you create biofuel and feed it into a car. And one is you use your land to grow wheat, turn it into bread, feed a cyclist. Another is you put a solar panel on that land and use that to drive a car. Or another is you put the solar panel on and you power an electric bike with it. And so this is how many miles per year can you get out of one square meter of prime land in California. So there we go. The biofuel, 5 miles. And there's a little piece of string you might just see there to illustrate it. The cyclist, bit of a bigger piece of string, 25 miles. The solar power for the for the car, 1,000 miles. And then finally, the electric bike, 21,000 miles. There we are, 21,000 miles a year from 1 square meter of land. Isn't that fantastic? Actually, I'll still be using the pedal bike, but just because it's nicer. But okay, so that's a quick tour of some of the stuff. I haven't touched on all of it, but some of the stuff in the sort of physical challenges we need to deal with. But what would it take for us to be dealing with them? So, on to questions of, that I've mentioned, the stuff in blue. So, I said economics. So I haven't got time to go through all of it now in much detail, but just to kind of touch on it all. So, a huge challenge to the way we think about our economics. So to start off with growth. So some people are saying, well, growth must be the root of all evil because GDP growth tracks with carbon emissions growth, and it always has done. And that's absolutely right. On the other hand, I would say about GDP growth that GDP is just an abstract human construct. It doesn't actually mean anything physically on the ground necessarily. So at least in theory, I can believe in the concept of a world in which GDP goes up and our environmental impacts go down. Having said that, it's completely the wrong metric to be chasing. It's completely divorced from the health of people and planet. And it's not something, it's just the wrong metric. We need to be tuning into metrics that are far more closely aligned with human well-being and planetary well-being and the well-being of other species. Business, there's a bit on business. I do a lot of work with businesses of all sorts of different sizes. And one thing that's clear on that is that it is no longer acceptable here in the Anthropocene to have a business whose primary objective is to make money. The world is just too fragile for that. And if that's your primary objective, you will end up smashing up the world. And so we need to have businesses it's okay to make some money, it's okay to earn a living from it, but we need to have businesses that exist primarily to be useful for people and planet. Inequality I'll come on to I think that's... So just quickly on some other forms of growth. So the question I'd like to frame up in terms of growth is not is growth good or bad, but what kinds of growth are good and what kinds of growth are bad now that we're in the Anthropocene. So here's my little diagram, which I draw as an exponential curve, just as it's my idea of a joke, really. Also, some people have challenged me on it. But I just thought I'd do an exponential curve just to kind of look reassuring to people who are fixated on the idea of growth and find that kind of thing reassuring. But it's just, what kinds of growth do we need in the Anthropocene, and what kind of growth do we not need? And so greenhouse gas emissions are clearly bad. We can't grow them anymore. Meat consumption, that's bad. We can't grow that anymore. GDP growth, that's very dangerous at best, but I can imagine conceivably that we could keep growing it. Population growth, we can grow that somewhat. Actually, the less we grow our population, the easier things are going to be for us. And it is a huge part of the whole sustainability equation. But it's not the single issue that some people frame it up as. But moving up to this end, what are the things that we absolutely do need to grow at high speed? Well, we need to grow our capacity for global empathy as quickly as we possibly can, so we actually get physically excited about things that affect the lives of people on the other side of the planet from totally different cultures that we're never going to meet. And we need to grow our qualities like our compassion for the people around us and the other people on the planet, because we're all in this together, like it or not. So even if you just take this from a practical perspective, unless we can tune into this idea of a global tribe, we won't thrive on this planet, because we are a global tribe, whether we like it or not now. It doesn't mean to say we can't still identify at a local level, but one of the units that we need to really strongly identify with is at the global level now. It's okay to still aspire to growing human well-being and well-being of the planet. So it's not that we can't have growth, it's just that we need to change the flavour of the growth that we push for radically. Just quickly, a little bit on inequality. So one little graph here. So why are most Americans poorer than most Italians? Because we think of America as such a rich country, don't we? And there it is, the third richest in my little graph there. That's the wealth per person. But let's compare that with that's the mean wealth per person. Let's compare that with the median wealth per person. That's the wealth of the person who's kind of sitting in the middle in the country, as many rich people richer than them as poorer than them. And there it is in yellow. And suddenly the States is one of the poorest countries of all of these. It's still ahead of China, Russia, and India, but it's way behind Italy and Spain, that we think of as much poorer countries. And why is that? That is because the wealth is in the hands of so few in the States. And the UK is on here as well, and we're one of the richer countries, and we suffer from the same thing as the States. We have not quite as bad, but we still have a huge inequality and rising inequality problem. And it's completely wasted. The energy, if you put all that money into just a few hands, it's completely wasted, because there's plenty of evidence that says beyond a certain level of wealth, which isn't very high actually, the correlation with well-being completely breaks down. And so here are the 10 wealthiest people in the US. And just to illustrate the point, I mean, the correlation with well-being must break down, because these people they've got hundreds of billions of dollars between them. If there was any correlation, they'd all just be going around in a delirium of ecstasy. And they're not. They're actually no happier than you or I. But if you just trim them down to being just billionaires, so not going to inflict any suffering, just trim them down to $1 billion each, and shared the rest of it around the poorest half of Africa, you could quadruple the wealth of the poorest half of Africa. That's just 10 people. And so, that's somehow we need to deal with that if we're going to get on top of these questions. There's a whole chapter on truth and trust in the book, because one of the things that's going on is that here in the Anthropocene, the issues are more complex than ever. It's easier than ever for a politician or anybody or a media source to pull the wool over our eyes because of that complexity. Yeah?
I'm sorry, I was just talking a bit and I started to ask the question. So I'm not sure all of them are really Americans, or is it that their wealth came through America? What exactly? Some may have other backgrounds.
These 10 faces, I think they all are American. Those 10 are. But I mean, they're not the 10 wealthiest people in the world. They're the 10 wealthiest people in America. But they are a good chunk of the wealthiest people in the world. Yeah. Yeah. I mean, I just put them up to illustrate them. I could have put other faces up and made the same sort of point. Yeah. So the question of truth and trust. So we need to get much sharper at this, because, on the one hand, it's easier than ever to pull the wool over our eyes because the complexity of the issues is going up and up and up. And on the other hand, because of that complexity, we need the clearest view of the truth that we can get, as far as it can ever be discerned, that we can get in order to navigate our way intelligently through the issues. And so we need to get just far sharper at asking ourselves, when we see a bunch of faces like this, asking ourselves, do we have a really good basis for working out which one of those faces we'd trust? which of those we trust the most, and what is that basis? Is it to do with their charisma, or the fact they talk with confidence, or the fact they went to Eton, or is it because we know they've got a track record of telling the truth, or is it because their arguments make sense, or is it because, what is it about them that leads us to have a really well-grounded basis from working out that they are giving us the clearest view of the truth that they can? And if they haven't, we need a really clear way of taking action on that and insisting and making sure they don't get our vote, and they know they're not going to get our vote, and they get called out on it. And it's not just about kind of obvious things. It's about, it's about digging into whether people are really being congruent with us. So, for example, more and more of the faces on that board now are saying, yeah, climate change is a really big deal and we need to do something about it. But we need to be asking them, are all your policies coherent with that now? And if they're not coherent with dealing properly with climate change, is that coherence because you hadn't spotted that it was incoherent, in which case go away and come back with something new? Or is it that you'd hoped that we wouldn't spot that was incoherent? And, if there's one thing we can do now, it's really pushing our politicians for coherence. Yeah, it's a very tall order. So we've been going backwards, right? We've absolutely gone backwards for a time, and my hope would be that we see what trouble we get into if we're casual with the truth, and now we more than ever we take ourselves into an era in which we insist on the truth in a way we've never done before. And the same goes for our media sources. Ask yourself carefully: is my media giving me the best version of the truth it can? And if not, just switch. And there's some guidance on that in the background, in the book as well. So, simple non-rocket science things like ask yourself about their funding and their motivations and stuff. Just quickly on the inequality and getting ready for the discussion of values, and the Financial Times said, well, why did you put that in? It's a bit irrelevant, wasn't it? But this is just on prison statistics, and partly just because it makes your eyes pop out looking at them. If you are a male born in Louisiana, the mean amount of time you can expect to spend in prison in your lifetime is coming on for 2 years. Right? A male born in Louisiana, 2 years. If you're a black male, it doesn't bear thinking about. It's much better if you're a woman, by the way. If you don't want to go to prison, you're much better off being a woman. In the UK, we have, it's a lot better, but going up a lot. It's going up rapidly, the amount of time we can expect to spend in prison. And then there's a discussion in the book about, what do we, what is the value that we attribute to different people and why? And what happens, what about people in prison? What's the best way of, what's the best way of thinking about them? And there's a quote from a guy who runs a prison in New Zealand who says, well, what do you want when your prisoners come out of prison, what do you want? Do you want them to be angry, or do you want them to be rehabilitated? Okay, so as I say, I'm just going through sort of snippets from the book, but leading into this values discussion. And it's amazing how many technical and scientific experts I talked to in the writing of this book, who at the end of a long cup of coffee would say words to the effect of, you know what, maybe at the end of the day, it all boils down to a values debate. If you're talking about how to feed the world, well, maybe at the end of the day, it's just all about values. If you're talking about how to get a deal to leave the fossil fuel in the ground, well, maybe, if we've got the right values, we can do it, and if we haven't got the right values, we can't. So what are those values? And I'm not saying this, I'm not trying to say this to be preachy. I'm just, I've got no more credentials for talking about this kind of thing than anybody else. So I'm just approaching this from a purely pragmatic point of view. Are there some values that will allow humans to thrive in the Anthropocene, and values that if we don't have them, then we're going to be in trouble? And just by the way, the evidence is that we can, by deliberate effort, change our values. We can, but through deliberate effort, make values culturally normal. And that is really good news. And there's evidence from neuroscience and history and all over the place that this is possible. So just very simply, just 3 values, really, really simple. The first is just that to treat all people as if they're of equal inherent value as human beings, whoever they are, wherever they come from in the world. And maybe it sounds too obvious to say, it's just that if you think about what it would take to start living like that, you'd have to unpick just about everything about life in the UK. So it's a massive, simple and obvious concept, but hugely massive challenge. Second up, to extend that to all the other species in the world, and not just treat them as servants of humanity, but to give them some respect in their own right. And that's in our own self-interest, because we absolutely need that biodiversity. And then finally, and I've mentioned it already, is to respect truth for its own sake, whether it's convenient or inconvenient or painful or difficult or whatever, but we've just got to get really passionate about just hanging on to it as a concept, as a principle in every situation, even when it doesn't support the cause we're trying to promote. Okay, so I'm sort of coming-ish towards the end. A little bit to go, but the conclusion of the book just talks about thinking skills. So are there some thinking skills and habits that we need to develop at a high speed? And I've got my little map of 8. So the first is we need to get much better at big picture thinking, because suddenly we're in this world in which, humans are great at doing the detail, but we need to get much better at standing back and seeing the whole holistic picture. And aligned to that, joining it all up. We need to get much better at our global empathy as a kind of a skill. We need to get better at having an emotional reaction when something goes on that affects people on the other side of the world. Better at appreciating small things locally. I'm not, by the way, claiming to be a genius at all these skills at all, but I'm just identifying them as things I think, if we could all work on them as best we can, so that we don't have to get on an aeroplane and fly to the other end of the world to get our kicks. The truth questions are about critical thinking, so we can get smarter at working out when we're getting a good view of the truth, and a personal reflection side of that, so we can get better at working out, understanding what's making us think what we're thinking. Are we not facing up to things just because they're difficult to face up to, or what? And then finally, this ability to do complex thinking and work our way through complicated problems, because the world is getting more complex. And if you just look at, for example, what it would take to sort out the UK's energy mix, actually that's a really complex bit of solutions. It involves all kinds of different things coming together, and we need to be able to solve that sort of, the kind of problem solving we need for that is just way above the kind of problem solving that's currently going on in the energy industry at the moment. So getting towards the end, just to say, what might we aim for? Because it sounds like doom and gloom. I don't know, we could all do different pictures. This is my Lake District-centric collage of things that are, what a better future might look like. And we could all do different versions of this, and they might look very different. But, just to make the point that this is not about going around wearing hair shirts. This is about liberating ourselves from loads of things that we do in life that just trash the planet and don't make ourselves happy, and just get far smarter, if we can, at living in a way that is good for people and planet at the same time. So, if we're clever about this, it's a re-engineering opportunity to actually enhance life rather than detract from it. And, it's not that there won't be some difficult things, there will be some bullets to bite along the way as part of it. But just notice, by the way, that I have got room for a little aeroplane in here. Not a very big one, but there is some flying in the low-carbon world. And then, finally, so people ask the question, I've talked about how it's all global systemic stuff, and it is. And if it's also global and systemic, what can any of us do? Because, it's a legitimate question. Maybe an individual can't do anything about it. It's easy for us all to feel like we're just a speck. And I don't think that's the case at all. The question to ask, though, is, what can I do to help create the conditions under which the world can have the system change that is required in order for humans to start thriving in the Anthropocene? And that's a different question from how can I cut my carbon footprint. It includes that, but it's a much bigger question. And where I've got to is, so first, a few things. So, when it's also global, what can I do? It turns out there's absolutely plenty. The first thing is we don't spend anything like enough time imagining how good things could be if we played our cards right. We need to imagine how bad things are going to be if we don't play our cards right. We need to imagine really well how good things we could be if we do play our cards right, and then we need so that we get a strong sense of the difference that we can make if we act one way compared to another way. We need to role model things as best we can, and by that I mean we don't all need to be perfect. None of us are. You know, we're all living in a conflicted way. You can't be in today's society without having conflicts in your life. So it's not about beating ourselves up for our imperfections. It's not about letting ourselves off the hook either. It's about moving on in the best way we can all the time in serious and important ways. And it's about being creative about it and finding ways, inventing ways of making life better, not worse, as we do it. So it's a creative project. I've talked about the skills and values that we need to have, and it's about us all developing those as best we can and helping others to do as well, not least through education. It's about influence, so asking ourselves, well, where are the places where we can have influence? In our schools, in our workplaces, in our social environments, perhaps most challenging of all, in our families, in the way that we vote, but not just in the way that we vote, in the way that we influence our politics, in the way that every time you spend money or in any way at all, you're pushing for one future or another. So it's just about asking, where can I have influence, and trying to have that influence kind of all the time. And it's about insisting. We've had decades of asking nicely for some action on climate change, for example, and it is absolutely time to insist on it now. We really don't. It's not proven that we can't get out of the mess that we're heading for, and so we should absolutely be working at it as hard as we can. And it is time to insist. And I don't say this lightly, but it is time to, in a careful and clever way, it is time to protest, I think. And I absolutely take my hat off to Extinction Rebellion for some of the stuff they have been doing. And I know there's at least one person, or at least a few people from there in the room tonight. But, it has to be cleverly done, and it has to be constructively done. And, I wasn't sure what I'd make of Extinction Rebellion, but the way that they insisted on respect of everybody, and the way that they called for truth. Well, all the three values that I've just put up, they were really hot on all of those, and they were very constructive about it, and they were equally very clear and insistent about it. And the school kids going on strike, that's very healthy as well. So, there are some causes for hope. These kind of things weren't around a little while ago, and a year ago, this sort of stuff wasn't around, and it is now. And I'm sort of mixed feelings about putting an MP's face up there, but I do feel as though we've got at least one Anthropocene fit MP, and we need hundreds of them, obviously. But maybe I shouldn't single just her out, but there are some good MPs. Okay, there we go. I've talked for easily long enough. That's the book. Thank you for listening.